Okay, multiplying radicals. You multiply your coefficients together and multiply the radicals together. Then you simplify and multiply your coefficients again if you have them. So if we had the square root of 8 and the square root of 3, 8 times 3, they're both under the radical, is 24. So we have the square root of 24. 24 can then be broken down into the square root of 4, that's your perfect square, times the square root of 6. So the square root of 4 is 2, and the square root of 6 stays the same. So 2 square roots of 6. If we had 5 square roots of 3 times 2 square roots of 4, 5 times 2 is 10. And then 3 times 4 is the square root of 12. And again, 10 would still break back down into that square root of 3, square root of 4. So you technically have 10 times 2 square roots of 3, which would then be 20 square roots of 3 as your final answer there. You could have also said, well, the square root of 4 is a perfect square. 2 times 2 is 4. 4 times 5 is 20, and then you just have the square root of 3. Both ways they work. So here we have that perfect square of 2 or 4. The square root of 4 is 2. And we're going to take 6 square roots of 2 times 2. So that gives me 12 square roots of 2. And then lastly, we have 3 square roots of 7 times the square root of 3. 7 times 3 is the square root of 21. And that 3 is just going to tag along. 21 cannot be broken down. It is simplified completely. So 3 square roots of 21. So also remember, when you multiply, you add your exponents when you have them with your variables. So here, 5 times 3, we're going to do that first. 5 times 3 gives me 15. On the inside, 12 times 12 is 144. And then x times x squared is x cubed. 144 is a perfect square, so I'm going to pull that out. So 15 times 12, and then I have my 3 x's on the inside. 1x is going to come out because we can group one set of 2. So we will have 15 times 12, which is 180. We're going to have an x come out, and we're going to have an x stay in. So 180x square root of x. Also, when you multiply a radical by itself, you end up with the number under the radical. So if we had the square root of 6 times the square root of 6, that is technically the square root of 36. Square root of 36 is that perfect square, so you end up with that number underneath the radical of 6. Same thing here. Square root of 2x times the square root of 2x is the square root of 4x squared. All perfect squares. 2x is your final answer. Lastly, distributive property also works because it is a part of multiplication. So I'm going to distribute this square root of 5 into everything. So the square root of 5 times the square root of 3 is the square root of 15. Square root of 5 times the square root of 5 is the square root of 25. 25 is a perfect square. So we have the square root of 15 plus 5 as your final answer. And even the distributive property works when you don't have that square root. So you're still going to multiply these, but they're not going to change the number. So you'll just technically have 4 times the square root of 3. And then 3 times 10 is 30. So plus the square root of 30. And the square root of 30 does not break down. So you have 4 square roots of 3 plus the square root of 30 as your final answer. So your homework is to complete the worksheet. Again, it does not get turned in just like last night's. Keep it in your notebook. It's posted on Schoology. And that's multiplication. It's really simple. Once you understand how to simplify, everything is easy through here. If you have any questions, let me know.